Hello and welcome. In today's video, we're going to be introducing section 9.1 on properties of radicals. Our essential question for this section is how can you multiply and divide square roots? So we're going to go ahead and explore some different properties with exponents, and I'd like for you to take a minute and pause the video and practice going through these 4 cases on your own, and then I will walk through them with you. So go ahead and pause the video and try these now. Part A, we are exploring square roots and addition. So I've got square root of 36 plus square root of 64, and we want to see if I add first and then square root, do I get the same thing? Well, the square root of 36 is 6, the square root of 64 is 8. When I add the two, I get 14. Well, here we're saying add them first, so I go ahead and I add 36 and 64 to get 100, but the square root of 100 is 10. So this case is not true. Square root of 36 and square root of 64 does not equal the square root of the two added together first. So we cannot simplify by adding. What about multiplication? Square root of 4 is 2, square root of 9 is 3, and then when I multiply, I get 6. If I multiply first, 4 times 9 is 36, and then if I square root, I get 6. So multiplication looks like we can split up our radicals with multiplication. So here, yes, it does work to combine those two under one radical. With subtraction, 8 minus 6 is 2. 64 minus 36 is going to be 28. And the square root of 28 is not 2. So this is going to be not true as well. So just like with addition, we cannot combine two radicals with subtraction. Now what about division? Square root of 100 is 10, the square root of 4 is 2, and 10 divided by 2 is equal to 5. Now if I combine them into one radical and divide first, 100 divided by 4 is 25, and the square root of 25 is also 5. So both of these did simplify down to 5, which means that our radicals can be combined with division. So we can combine radicals under multiplication and division, but not with addition or subtraction. So we're going to be talking about simplifying radicals using these properties. So using properties of radicals. A radical expression is in simplest form when the following conditions are met. No radicands have perfect nth powers as factors other than 1. So that means that our exponents are simplified as far as they can go. No radicands contain fractions, so underneath the radical we don't have any fractions. No radicals appear in the denominator of a fraction, so that means that we don't have anything such as this, where we have a radical in the denominator of a fraction. And we can use the property that I'm going to walk us through below to help us simplify radicals. So to simplify radicals, essentially what we're going to be doing is breaking them up into perfect squares. And then we are going to split them up because we did see that we can combine a radical over multiplication, which means that we can always also split it up over multiplication. So in this case, we started with the square root of 45, and then we said, actually, this is the same thing as the square root of 9 times 5. And the reason that we do that is because 9 is a perfect square, and since we are multiplying, I am allowed to split these up. We did see that this is the same thing as multiplying them first. And now I can simplify the square root of 9 down to 3, and the square root of 5 does not simplify, so I've got 3 times the square root of 5. So splitting up radicals does help us to simplify as far as we can. So to do this, I'm going to start by factoring my 108, and I'm going to be looking for perfect squares. I do know that 108 divides by 2, and I'm left with 54, but neither of these are perfect squares, so I'll keep factoring. I've got 2 and 27, and I can continue to factor 9 times 3, so 9 is a perfect square. And 2 times 2 will also give me a perfect square. So if I rearrange these factors, I've actually got 4 times 9 times 3, which will give me 108. So I'm going to split up 108 as the square root of 4 times 9 times 3. So that tells me that I can split this up as separate radicals since we are multiplying. Square root of 4 times the square root of 9 times the square root of 3, which is 2 times 3 times the square root of 3, simplifying down to 6 times the square root of 3. There are definitely other ways that you could have factored this down. You didn't have to go about it exactly the way that I did, but this way is one possibility. For B, I know that 9 is a perfect square, so I'm going to split up my 9 with my x to the third power. Now, x to the third power is not a perfect square, but x squared is. So what I can do is split this up as x squared multiplied by x. So these two give me x to the third power. I just split them up into two separate radicals. So what's going to happen with this x squared is exactly what's going to happen with the 9. Now we should know that square root of 9 is 3, and the reason that that is because 9 is actually 3 squared. So since 3 squared is 9, this exponent of 2 and the radical essentially are inverses or opposites and undo each other, leaving me with just 3. So that same thing's going to happen with my x squared. The radical and the exponents are opposite, leaving me with just x. And then I have the square root of x, which does not simplify. So this brings me down to 3x multiplied by the square root of x. Now I'm not too much of a fan of this process. I am going to show you another process that I prefer because when your numbers get larger, it can be difficult to break them down into radicals by identifying perfect squares like this. So my preference is to do the following. I am going to factor out each of the components of my radicand as far as I can. So I'm going to go ahead and break this down into 8 times 8. And then from there, I'll actually stop because what I'm looking for are pairs. If something pairs up, that means that it's allowed to come out of the radical. So this tells me that the 8's paired up, which means I can take an 8 out of my radical. Then I'm going to break up whatever's remaining inside my radical. So this is n to the fourth, or n times n times n times n. We are looking for a square root. Square root means groups of 2. So here's another pair of n's, which means I can take out an n. And here's another pair of n's again, which means that I can take out another n. Now we use everything inside the radical, which means there's nothing left inside the radical. So this 8 times n is everything that's been accounted for, and it simplifies down to 8n squared. So my radical simplifies down to 8n squared. I'll do this a couple more times for you. My 18 is going to factor into 9 times 2. Now there's no pairs there, so I keep going. 9 factors into 3 times 3. So my 18 is 3 times 3 times 2. So I see a pair of 3's, which means that the 3 can come out of the radical. The 2 unfortunately doesn't pair up with anything, and the 9 split up into the 3 and the 3. So there will be a 2 left underneath my radical. I'm going to look at my x's now. X to the third is x times x times x. So I see 2 x's pairing up. So that means that an x gets to come out of the radical. This leaves me with a 3 on the outside from this group, an x on the outside from this group, but inside the radical I still have a 2 and an x remaining. So my radical simplifies down to 3x times the square root of 2x. 80. 80 I will start by factoring into 8 times 10. No pairs, so I keep going. 4 times 2. No pairs, so I keep going. 2 times 5. I do see a pair of 2's. That's helpful. But I can continue breaking down my 4 into 2 times 2, and there is another group of 2's. Now if your number broke down into two smaller numbers, we make sure that we ignore it. So this 4 broke down into 2 times 2, so we no longer use the 4. The 8 broke down into two numbers, and the 10 broke down into two numbers. So I've got 2, 2, 2, 2, and 5. my a squared is going to break down into a times a, which pairs up. So now I'll list everything that was able to come out of the radical. I had a group of 2's. I had another group of 2's, so I multiply by another group of 2's. And then I took out an a, so I multiply by an a. But the 5 was not paired up with anything, so it remains under the radical. So I've got 4a times the square root of 5. Lastly, 320 times x, so I'll break this up into 32 and 10, which breaks up into 8 and 2, and 2 and 5. 8 breaks up into 4 times 2, and 4 breaks up into 2 times 2. So I will go find all my pairs. 2's pair up, 2's pair up, but there is a 2 and a 5 remaining. This x did not pair up with anything either, so that will also remain under the radical. So outside my radical, I have a 2 from my first group times a 2 from my second group, and underneath the radical, I have a 2, I have a 5, and I have an x, which leaves me with 4 times the square root of 10x. All right, your turn. Pause the video and try out these 4 on your own. All right, you can go ahead and take a moment, pause the video again if needed to check your answers here. Part 2. In example 2, we're going to be talking about the quotient property of square roots. Just like with multiplication, we can split up a radical with division. So what we're going to do is we are going to square root the top and the bottom separately. So here I'll have the square root of 15 over the square root of 64. So the square root of 15 I cannot simplify, but the square root of 64 is 8, and we are done. Square root of 81 over the square root of x squared. The square root of 81 does simplify to 9, and the square root of x squared does simplify down to x. So we have 9 over x. So go ahead and take a moment, pause the video, and try out these 4 on your own. Splitting up my radical, I've got square root of 23 over the square root of 9, or square root of 23 over 3. Here I've got a negative square root of 17 over the square root of 100, and the square root of 100 is 10, but the square root of 17 does not simplify, so here is my fraction. I split up my fraction into 2 separate radicals. Square root of 36 is 6, square root of z squared is z, and we're done. Numerator, square root of 4x squared over the denominator, square root of 64. This simplifies to 2x over square root of 64 is 8. Cube roots. Now cube roots are going to follow a very similar property as square roots, except now we're looking for groups of 3. 3 identical numbers that multiply to give you the number that you're looking for. So I'm going to go ahead and factor my negative 128, and I am looking for 3 identical numbers in order that they can pair up and come out of my radical. So here I've got a negative 2 times a positive 64. 64 is 8 times 8. 8 times 8 breaks down into 2 times 2 times 2, and 2 times 2 times 2. So I see a group of 2's. I see another group of 2's, which tells me that I can take out 1 2 from the first group. I can take out a second 2 from that second group, but there is a remaining negative 2 that did not pair up with anything. The only other thing I want to say is that a negative number can actually be broken down into negative 1 times negative 1 times negative 1 multiplied by 2. So I can actually take out this negative to the front as well. So I am going to have this as negative 4 times the cubed root of 2. For 125, that'll break down into 5 times 5 times 5. And x to the 7th is x to the 3rd, x to the 3rd, and another x. So I can take out a 5, an x, but there is an x remaining. So I've got 5 with 2 x's and the square root of x. Go ahead and pause the video, try out the remaining 6, and then I will have you check your answers in just a moment. All right, you can pause the video again to check your answers, but that brings us to the end of our video for today. Thanks for watching.